All right. This is our video for solutions to systems. First, welcome back. Just remember with the video, pause it, replay it, make sure it works for you. So here we go. A system is made up of two linear equations. So we're doing systems. So we have already done linear equations. Now we're going to be doing two of them, dealing with finding the solution that works for both of them. The solution to a system is the point of intersection of the two lines. So today we're going to be graphing them. We're going to find these solutions by graphing. That's what we're doing today. There's three ways. There's graphing, elimination, and substitution. Today we're doing by graphing. So we're going to graph both of these equations and find the point of intersection, meaning where they cross. Where they cross each other, that is your solution. And plug the ordered pair into the equation to prove that its solution is of each equation. So after we find where they cross, we're going to plug it in to make sure it works for both of them. So let's get started. Seems like a lot, but it's really straightforward. The main thing you have to remember is, how do we graph? Remember that equations come in y equals mx plus b, where this is our slope and this is our y-intercept. I know you've been gone for the break, but those are two things we still need to carry on. Alright, so if we start with the first equation, we're going to graph that one in blue so we can determine. If we start with the first equation, the y-intercept is at -4. So I'm going to start, this is 0, so I'm going to start at -4. 1, 2, 3, 4. There's my first point, and recall that then I'm going to use the slope. The slope is 3, so I'm going to go up 3 and over 1 to graph the next point. So 1, 2, 3 and over 1, 1, 2, 3 and over 1. And then I'm going to graph this as best I can. Okay, now that I've done that, I'm going to do the same for the next line. So this next line we're going to use green, and y equals -1/2 x plus 3. Just by looking at it, we know that it has a y-intercept of 3, but a slope that is -1/2, so that line is coming down. Okay, so we start at +3, 1, 2, 3, and then we're going to come down 1 and over 2. Down 1 and over 2, 1, 2. Down 1 and over 2. And then we graph it. If you're not remembering this, you need to go back and review your notes or watch a video on graphing equations, because all we're doing is graphing. Yes, there's two of them, but all we're doing is graphing. What happened is, now we can tell where it crossed. They cross right there. That's the point at which they cross. And that point is 1, 2 on the x and 1, 2 on the y. So according to graphing, the solution of these two equations is 2, 2. So that's one part of it. Then we plug it in to see if it works. So what's that mean? This is my x and my y. So I plug that into each equation and see if it works. So on the first one, y equals 3x minus 4. I plug in 2 for the y and 2 for the x. And then I go ahead and solve this and see what I get. 3 times 2 is 6. 2 equals 6 minus 4 is 2. So that one checks out. And now I do the next one. The next one is y equals -1/2 x plus 3. And then again I plug in a 2 for the y, -1/2 times 2 plus 3. Well, this is still 2. -1/2 times 2 is -1 plus 3. 2 equals 2, so that checks out. So 2, 2 is a solution. Are we going to have to check them all the time? No. This is the process to ensure that you know that you have a solution that it works. We're trying to show you that when you do it by graphing, you can check to see that you've picked the right point. After a while, you'll know this and you won't have to check it. Let's look at doing the next one. Y equals 2x, we're going to do that one in blue, plus 6. So we start at y-intercept of 6. So here's your 0, 0. 1, 2, 3, 4, 5, 6, right there. And our next point is 2, 1. So it has a slope of 2, so it's 2 up, 1 over. 1, 2, 1 over. 1, 2, 1 over. And if we ran out of space, we could do it opposite. Down 2 and left 1. And now we have our line. And then we graph the other one. We're going to graph that one in yellow. Y equals x plus 4. Remember, when there's nothing in front of the x, it's a 1. So that means the slope is 1. So we start at 4. So 1, 2, 3, 4. We start in the same spot. Then we go up 1 and over 1. Up 1, over 1. Up 1, over 1. Up 1, over 1. And it almost seems like it's not going to touch. So then we graph it. And when we graph it, over here it's going to touch. See? So it just means that I need to follow it in a different direction. It's going to touch right there. Okay, so we make our lines as good as possible, and it's going to touch right there. And that value is 1, 2, 3, negative 3, and positive 1. Now, since I did not notice them cross right away, and my lines are a little bit crossed, that's why we check it, just to make sure that it works. So we plug in, so we start with the first equation. Y equals 2x plus 6. We plug in 1 here, and because that's your y, and 2 times negative 3. And this is negative 6 plus 6. So this does not work because we notice that they don't match. They don't match. So therefore, that cannot be right. So I need to follow my way back to make sure that this works. So let's erase that. So notice what happens when we make a mistake. We can go back and redo it. So what I need to do is count my way back to make sure that this is working. So originally I was going up 2 over 1, so I need to finish that. Down 2, 1, 2 over 1. So it actually hits earlier than that. Okay? It actually hits earlier than that. And what I want to do is actually follow the yellow to make sure that it does go. This one's up 1 over 1, so down 1 over 1, down 1 over 1. So this is where it actually hits. So now you saw what happens if we just estimated a little bit wrong. That's why we're having you plug it in. Because sometimes when we draw our lines, they're going to be off a little bit. So you plug it in to make sure you got the right answer. So this is actually negative 2, positive 2. And now we check. Y equals 2x plus 6. Y is 2. X is negative 2. And now it should work. 2 equals 2 times negative 2 is negative 4 plus 6. Negative 4 plus 6 is positive 2. And we had a 2, so that works. And now I check it for the other one. The other equation was y equals x plus 4. So y is positive 2. X is negative 2. Negative 2 plus 4 is positive 2. And it checks. So again, if you happen to pick the wrong coordinate, you are able to check it prior to making that your final response. Alright, so then what happens when we have an equation that is not in the y equals mx plus b. Oh, let's get that out of there. When we have an equation that is not in the y equals mx plus b, well, we make it that way first. And we've done that before. Remember that we want y by itself. So we're going to draw our line and move our x to the other side. So now we have y equals negative 2x plus 2. And now we can graph that one. This one is also not in the y equals mx plus b. So we subtract the x. We have negative y equals negative x plus 4. We don't want negative y. We want positive y. So we divide by negative 1. It means that everything goes to opposite. So now I have two equations I can graph. And now I'm ready to graph to find that solution. Again, if that was too quick, pause it and rewind it. So now I'm going to graph these two. I'm going to graph this one in red. So that has a y-intercept of 2. So I'm going to start at 2. So here's our 0. So I'm going to start at 2. And then I'm going to go down 2 over 1. Down 2, down 2, over 1. Down 2, over 1. And now I graph. Okay. And then I graph the other one in blue. Y-intercept of negative 4. So I start at negative 4. 1, 2, 3, 4. And it has a slope. That's just x. So it's 1. So up 1 over 1. Up 1 over 1. Up 1 over 1. And now we found our point of interception. Now that I know my point of interception, well, I never drew my line, did I? Now that I know my point of interception, I write my solution. And that is 1, 2, whoop. It's just 2 on the x. And 1, 2, negative 2 on the y. Please know that most of our answers so far have had a 2 of some sort. It's not always going to be 2, guys. I know some of you guys are already looking and say, oh, it's always going to be 2. It is not always going to be 2. Alright, same thing on the last one. Again, if that was too fast, go ahead and pause it, rewind it. We're going to subtract our x. Negative 3y equals negative x plus 6. Divide by negative 3. Y equals 1/3 x. Because remember, there's a 1 there. Minus 2. We have our first line. Next one. Draw our line. Subtract the x. Negative 3y equals negative x minus 3. Divide by negative 3. Y equals positive 1/3 x plus 3. Okay? Some of you should be looking at this one now and be able to tell something. What can we tell about these two equations? We should be able to tell that they're not going to intercept. We know that because the slopes are the same. So they are parallel. But we're going to graph them so you can see that they will not intercept. I'm going to graph the first one starting at negative 2. So here's 0. Here's negative 2, and it goes up 1 over 3. Up 1, 1, 2, 3. Up 1, 1, 2, 3. And then we graph. We use a different color for the next one. And we'll see that it starts at positive 3. So even though 1, 2, 3, it starts at a different spot, it goes up 1 and over 3. Up 1, 1, 2, 3. Up 1, 1, 2, 3. And they will never intercept. Now those are not straight lines, but they will never intercept because they were parallel. So that's what we call no solutions. Okay? The solution on the other one was 2, negative 2. On this one, if they don't intercept, it has no solution. Alright, again, if you need to find the solutions to these, pause and rewind and get your answers.